Today we're going to continue our work with right triangle trig. Today we'll be finding missing angles in right triangles. But before we get started, let's have a riddle. A cowboy rides into town on a Friday, stays 3 days, and leaves on Friday. How is this possible? His horse is named Friday. Okay, before we jump into today's lesson, let's recall our last lesson on finding missing sides. The first thing we do is we look at what angle we have, and then we see which sides are involved. Touching the angle is always the hypotenuse across from the right angle and the adjacent side. So we ask my friend Sokatoa, say his name, Sokatoa. And we see that adjacent and hypotenuse belong together for cosine. So we write cosine of the angle, which is 59. We put the first one on top, which is adjacent. That's our missing side x. Hypotenuse on the bottom is 13. In order to get x by itself, we multiply both sides by 13. I like to always put the 13 in the front so that I don't accidentally multiply it by 59. So everybody grab a scientific calculator and make sure that you know how to punch this in for yourself. Put 13 multiplication cosine of 59. If you do that properly, you should get 6.6954 and some more digits. Normally we round to the nearest tenth, so that's 1 decimal. You check the very next digit. If it's 5 or higher, that means we round up. So x is approximately, we round off, to 6.7. We ask ourselves, what are we finding? It's a side, and that would be measured in centimeters. Okay, now let's start with example 1. This is going to be a little different because we're not looking for a side, we're looking for an angle. But we use the same process to start. We identify our angle. Angles touch the hypotenuse and the adjacent side, and the side that it's not touching is called the opposite side. So again, ask Boo Daddy, Sokatoa, where opposite and adjacent belong. They come together here. So we write tangent, that's what the T stands for, of theta. Since we don't know the angle, we put the opposite on top since it goes first, and adjacent on the bottom. Now, some people would say, let's divide by tangent, but that's just like saying, let's divide by subtraction. It doesn't work. It's an operation. So the way we undo it is to take the inverse tangent of both sides. And I like to do both sides separately. So that's what cancels the tangent out. And we have theta equals inverse tangent of 15 over 7. Grab your calculator. You're going to have to hit the shift or the second button first in order to get the inverse tangent. Also, it'd be a good idea to use your fraction key on this part. And you want to try to make it look just like this to get your best answer. So once you punch that in, you should get that theta is 64.98. Again, if we round to the nearest tenth, we check the next number to see if it's 5 or higher. It is. And we go up. That turns to a 0, which now turns this into 65 when we go up. If we're again looking for the nearest tenth, we show that decimal place. Now, when we try to figure out units, we have to remember this was an angle, so that's measured in degrees. Be careful not to put feet. Let's proceed to example 2. Again, see what sides are involved. I'm touching 2 sides. One side's always the hypotenuse that I touch. The other's the adjacent, but it's not involved. Across the triangle is the opposite side. Remember, across from the right angle is the hypotenuse. Across from the other angle is opposite. So again, Sokatoa, please help me. So opposite hypotenuse belong to the sine function. So sine of beta, another Greek letter, opposite goes on top. And again, we're doing the inverse of both sides. And we see that beta equals the inverse sine of 64.8 over 71.3. Again, don't forget to hit second to get the inverse, also known as arcsine. However, this is different from the cosecant if you're familiar with that. This is totally different. If we punch this in and round correctly, we see that our angle is approximately 65.3 degrees. Again, when you're looking for an angle, it's measured in degrees. Now, our last and final example. As a matter of fact, go ahead and pause your video and give yourself an opportunity to try this before I show you how to work it. Okay, now that you've hopefully tried this on your own, you found that we have touching, so this is adjacent. The other side that touches across from the right angle is the hypotenuse. Adjacent and hypotenuse. Sokatoa. Don't you just love the name? Adjacent over hypotenuse. We're going to put a cosine of the angle is adjacent on top. And if you want, you could go ahead and cancel those 4's out. 4 over 4 is just 1. And now, of course, we do the inverse cosine. So that cancels. We have alpha equals inverse cosine of radical 3 over radical 6. And if you punch that in correctly, you'll see that we have 45 degrees. That's familiar. Remember before when we did 45, 45, 90, which is what this is, we found that if you multiply by radical 2, you would indeed get the hypotenuse. And hopefully you see that did happen here.